So you are at Building Delightful Distributed Apps with Dapr. My name is Dustin. It's a lot of D's. If you want to check out my website or the code that we're going to talk about today, both those links are there. I'll also show them at the end on another slide. If you have any questions or want to participate or comments or any of that kind of stuff, just go ahead and throw them out. This is conversational. I don't have to, talk at you for the next hour or so. Feel free to jump in with questions, especially when we get to the code part. It's going to be a little bit of a choose your own adventure. So if there's something you want to look more closely at, or if there's something that you're interested in asking, go for it. I'm not guaranteeing that I'll answer all the questions, but I'll give it a shot. So with that, I want to talk about the backstory for this particular talk. So I'm on a project, and this project has some quirks. The first quirk is that we're building a complex distributed application. We're using microservices. We're going to end up using, we're going to need to use like a service bus to kind of do pub sub and keep everybody synced up. And we're kind of living that lifestyle. But there are some challenges on that project that are interesting. The first and probably biggest challenge is that our client doesn't know what cloud they want to be on. They don't know where they want to be in the cloud. So they're on OpenShift now, which is sort of an internal version of Kubernetes, which is great. Sure, that's a perfectly legitimate way to go to the cloud, is an internal cloud. They hired us to put them on Azure, and that's good. We like Azure. Azure's nice. But the people from AWS, wined and dined the executives. So now they kind of want to go to AWS, but they don't really know what they want to be. And so they kind of go back and forth between these. And currently we're on Azure, so hopefully that remains through the end of the project. But, we need something that's flexible. In addition, we have a lot of developers on the project. And, we don't want to have to spin up a million little service buses for all the developers. We don't want to make the project any more complicated to deploy. So we have some issues with infrastructure. And that's, and in my research to try and figure out some ways around that architecturally, I found this tool called Dapr. And Dapr solves a couple of problems with distributed cloud applications. There's a few things about writing distributed cloud apps that are painful. The first one is there's just a lot of moving parts. Not only like moving parts in the fact that you have lots of little services on your machine that you have to orchestrate and run and figure out. So like each individual service is simple and easy to work on, but collectively they can be kind of a pain. You also have lots of cloud dependencies. So if you're building distributed cloud apps, you have lots of, deployments in Kubernetes, and you have lots of, databases and have service bus and other cloud dependencies. And the thing about cloud dependencies is that makes local development very difficult, because then you either have to fake it somehow. And in Azure, there's a couple of ways to fake certain things. Like it's relatively easy to fake like a storage account, for instance, but it's a little harder to fake a service bus. It's not easy to do. And so all these things, make developing distributed cloud apps more difficult. And, the tool that I found that's going to help alleviate that is Dapr. So today we're going to talk about a couple of things with Dapr. One, we're going to talk about what it is. We're going to talk about how to use it. We're going to talk about some of the pitfalls. It's not all, happiness and sunshine. It's just like any other tool. There's some trade-offs. And then we'll talk about where you can find out more. In addition, we'll walk through some code. I'll show you a full end-to-end example using Dapr so you can get a feel for how easy or hard it is. And, by the end of this talk, you should have enough information to go out on your own and learn about Dapr. So let's start off with Dapr. Dapr stands for the Distributed Application Runtime. It's got a cool logo with a hat and tie because it's very dapper. It is an open source application runtime. So basically what that means is it's open source. So it's a cloud native computing foundation project. And it's a runtime, so it helps your application. So locally you can run your applications in Dapr, or alternatively, when you go out to the cloud, you can run Dapr containers that go alongside your application. And it is component-based. So Dapr gives you these pluggable Lego bricks that you can use. And there's a bunch of different components. You can make your own if you want to, and you can use some or all or none of them. Dapr does not care. And the way I want you to think about Dapr from kind of a high-level perspective is that Dapr is dependency injection for infrastructure. So instead of directly talking to a service bus or a storage account or a Redis cache or some of these other things, instead you can talk to Dapr, and Dapr will do all of the schlepping for you to whatever cloud service you need. And then you can inject, a different dependency if it, is better for you in local development. Dapr, D-A-P-R, is not Dapr, D-A-P-P-E-R. Throw up an emoji or something if you've used Dapr, the ORM, which D-A-P-P-E-R. So, again, Dapr is a pretty cool ORM, but it is not, it's not the same thing. Just a little bit of, I really wish that the Dapr people would have, really named their stuff something else, but, especially because Dapr, the ORM framework, definitely came first by a long shot, but, there's 2 problems in development. It's naming things and cache invalidation. Yeah, exactly. Stealing names is easy. Much like the Honey Badger, Dapr does not care about what cloud you're on or what programming language you're using. Because Dapr uses HTTP or gRPC to communicate, it exists, from your application's perspective, Dapr is basically a little microservice that it can call for different things. And because it speaks HTTP or gRPC, pretty much any language that can make network calls can use Dapr. So Go, Node, Python, .NET, you can make an R app that uses Dapr. Dapr does not care. That being said, there are SDKs that make your life a little easier in these languages that are shown on the slide. Specifically, what we're going to look at is the .NET API, which is super nice. So, there's some advantages, but, from the perspective of cross, compatibility or, having different, different things, Dapr is cross-language, which is really nice if you're building infrastructure. You don't have to mess with a bunch of different APIs. You just use Dapr to define all of your components, and then, you can have your buddies working on a Node service, and you can work on .NET, and everybody can talk to the same API, which is kind of cool. Similarly, Dapr does not care about which cloud infrastructure you use. It does not care if you use Azure or AWS. It doesn't care if you're on the local clouds. It doesn't matter. Because there are connectors in Dapr that will connect to different cloud services. Not all of them are supported at the stable level, but for each Dapr component that you want to integrate into your service, it will have a list of different levels of compatibility. So, obviously your main clouds are going to be well supported. Usually in Dapr, one of the kind of on-prem options is well supported. So for Service Bus, I want to say Kafka is a first-class citizen, but also Azure Service Bus. And then there's 7 or 8 other ones of varying levels of support. If you don't like either of those options, you can also DIY your own connectors. I personally haven't found the need to do that because I'm just learning Dapr to solve my problem on my application, so I don't need to, jump out and do more things. So this is good enough for me. Dapr works in a component model, and what that means is there's different building blocks. So these building blocks are exposed to your application as an HTTP service. So there's a bunch of them. There's you can use it to call services. So for instance, if you want to talk to the Twilio API or the Twitter API, you can use a Dapr component to set that up for you. If you want to implement caching, you can use state management. If you want to mess with a service bus, you can use the pub subcomponents. And there's a bunch of other ones too. There's secrets if you want to store secrets. And what's nice about these building blocks is you can use some of them or you can use all of them. And you can switch the backing provider of each of those building blocks as you move through your environments. For example, if you're using secrets, you can use locally, you can just use a file. You don't have to do anything special. Your application, same API. But when you go to your dev and QA and other environments that are actually deployed, you can use an Azure Key Vault for your backing store. And your application doesn't need to talk to the Azure Key Vault, it just talks to Dapr. and Dapr will give it the secrets it needs to run, whether they come from a file or an Azure Service Bus. All you need to do is change the configuration and inject the dependency into your application as needed. So what's nice about this is it makes local development a lot easier versus having to spin up a bunch of cloud resources. It also makes your ability to move from cloud to cloud much more doable because you're abstracting away those cloud services. Dapr works on the sidecar pattern. This is a pretty common pattern in like Docker and Kubernetes where you have your main application and then it gets a little buddy application to go with it. It gets a little buddy container that rides along with it, the sidecar. And sidecars generally do sort of cross-application functionality. So for example, there are sidecars that will do like retry logic and availability. So if you don't want to install Poly into your app and do all of that in your code, you can do it in your infrastructure instead by adding a sidecar, and Dapr works in a similar way. So when you deploy your application to your cluster or wherever you deploy it, Dapr will come in as a little sidecar. Your application will talk to Dapr just like it's another application. Basically, it's a little web API, and that will be how Dapr interacts with your app using the sidecar pattern. Does that make sense to everybody? I'll assume that means yes. Security is important, and in Dapr, there's a couple of different ways to scope your components. So when you define your building blocks, you define your components, you can scope them by application. So for example, if you scope like a key vault component, you can say, well, that key vault is only for my application and the services in it. Or alternatively, if you have something that's super sensitive, like maybe you have a cache of bank data or something or some sort of PII, you can actually scope that down to individual component apps in your service. So you can say, well, only these like 2 services can use this component, and then everybody else has no access to it. So you have a couple of different scoping options in Dapr that you can employ to kind of add some security to your services. So when you define these components, they aren't available to everybody. You can scope them down as needed. Hosting, there's a bunch of different ways to host Dapr. So locally, you can use the Dapr API, and you can just run your code, using Dapr, using the Dapr command line, and it will, basically wrap your code in a Dapr container. That's one way to go. Another way, which to me makes a little bit more sense and what we'll demo today, is using Docker Compose to define your Dapr containers and your environment and your relationships. Once you go out to your deployment environment, Dapr works really well with Kubernetes. And then also certain services in the cloud have Dapr built into them. So in Azure, AKS can have optional Dapr support built in. That's a preview feature, but you can also get Dapr with Azure Container Services. I'm fairly sure you can get it with functions as well. So if you're using Azure specifically, there are some options. I don't know if they have the same kind of deal in GCP and AWS, but if they don't, they probably will because everybody seems to copy everybody anyway. So just as an FYI, so you can use it locally, in a variety of ways, or alternatively, when you get out to the cloud, if you're in Azure, you can use it in a couple of different ways. So you got some options. Though I think for most folks, it's going to be using Docker Compose locally and then Kubernetes, whatever flavor you're into, whether it's AKS, EKS, OpenShift, Rancher, whatever, when you go to deploy to your environment. Use cases. Overall, Dapr is super good for microservices architecture. Dapr shines in polyglot environments because it just talks HTTP, so you don't have to rely on a specific language stack to use Dapr. It's not like just a .NET thing or just a Java thing or whatever. And it's really good for multi-cloud because it gives you that dependency injection. So if you have an application that runs in AWS and in Azure, you can just swap out your components and you're good to go. Dapr is less good for monoliths. So if you have just a big monolithic legacy application, Dapr is probably not for you. I'm not saying it's going to be completely pointless. It's just that, from a use case perspective, it's just not as useful on that kind of application. So, if you're in the cloud native ecosystem if you're trying to get some of that dependency injection, make local development easier, etc., give Dapr a look. If you're, on-prem and you're slogging away at some, .NET 4.5 web forms app that's never going to go to the cloud until you rewrite it, well, Dapr's probably not for you, at least at this point. Dapr will be for you when you rewrite that application eventually, hopefully. Good times. So how do you get started with Dapr? Prerequisites for local development, you're going to need Docker Desktop or some flavor of Kubernetes, probably Docker Desktop. And to run the stuff that we're going to talk about today, you're going to need .NET Core. .NET 6. I should correct that slide. .NET 6 is .NET Core. It's just not labeled that way. Fun fact. The first mode that you can run is self-hosted. So in order to do the self-hosted mode, the first thing you need to do is you need to install Dapr, the Dapr CLI, using that PowerShell command up at the top there. It downloads Dapr, installs it. Then you can do Dapr init. That's going to spin up your Dapr containers. And then you can modify your components in your user profiles. It's in the .dapr folder, and then you can run using the Dapr CLI. This is the way they tell you to do it, at least in all the Hello World Dapr examples. But I'm going to be honest with you, I quickly outgrew this when I was trying to figure things out on my own. So your mileage may vary. The second way to do it is to use Docker Compose. And to me, this makes about 1,000 times more sense, even though it's a little bit more hassle to set up. And so in Docker Compose, you have your image. So you have here's your application image for your service. And then you add your little buddy Sidecar Dapr container. And then down at the bottom, you have your Dapr dependencies. So in the case of this, this slide, we're using Zipkin and Redis. And then down here, you have your Dapr placement, which is kind of like your Dapr central node that all the other Dapr things talk to. And so by defining that manually, you can also define a local components folder. And so for a particular application, you can keep your components in your application, which to me makes way more sense than trying to fish through your user folder or whatever to do that. I don't know. I just found that workflow to be really hokey, and this workflow makes more sense to me. Your mileage may vary. I'm not going to tell you how to live your life. After you have your Dapr stuff ready to go, you need to define your components. Dapr components are defined in YAML. So if you're running the command line, you go to your Dapr folder, your .dapr folder in your local users folder, or alternatively, if you're running in Docker Compose, I just like to keep them in the project because that makes more sense to me. Dapr components look like this. If you've ever seen a Kubernetes manifest file, this is going to look awfully familiar to you because it's the same kind of format. So you come in with the kind, which is going to be component. You add a name, so whatever the name of your component is makes sense. And then in the spec, what you're going to do is you define the type of component. So in this case, we are defining state, which is the Dapr component that deals with caching and storage. And so that's the type, and then .redis is the backing store. So basically, I'm defining a state component that talks to Redis. And this is basically a local version of Redis. So we're just running with a host. The Redis password is blank. We're running the default password. So this is a component for your local machine. If you want, this could be a Redis cache in Azure. So if you have an Azure cache or another Redis cache that you're running in the cloud, you would obviously put in different values, have a real password, that sort of thing. Or alternatively, you could use another backing store for your state. It's really up to you. So for dev, you can do this, and then when you go to other places, to other environments, you can swap this out and your application code remains the same. So once you have your components defined, then you got to add your application code. In .NET land, you have a very handy API for Dapr that has a Dapr client. And so here we have just a quickie example, and I'll show you the live code of this a little bit later. So we'll just kind of breeze through here, but you have a Dapr client. Here you're getting your states. Here you're, deleting your state. So, and here's another publish async event. So you basically have your Dapr components to talk to the API for you. I mean, again, you can also do HTTP calls, but if you're in .NET, there's no reason to. Just use the SDK. In ASP.NET applications, there's a little bit of additional setup in the program CS to hook certain things in and give yourself the appropriate, dependency injection from the application perspective. But it's just a handful of lines of boilerplate, and I'll show you that in a little bit. Pitfalls. Dapr is cool, but I don't know. Developing and learning Dapr over the last month or two has been interesting. Like when I first went into this, I thought it was going to be easier, and there's some things that were a little bit of a struggle to get up and running. The first are the docs. The docs for Dapr are great. There's a really good Microsoft book. The Dapr docs on the web are excellent, especially for high-level stuff. Where things kind of fall apart is that Dapr is relatively new, and the examples are not fantastic. So, for example, you're going to have, if you look at some of the examples, they don't necessarily delineate well whether you're running in self-hosted or Docker Compose mode. Sometimes it's just kind of awkward. Like there have been a couple instances where I've followed the listed steps to build something, and it's just been problematic. And it's not ideal. So while the Dapr docs are good, they're a lot better than most other new technologies. It's still a little bit of a struggle bus getting everything to work. And so what I found to get around that is to go straight to the source code. So if you find a couple of good Git repos, and I'll show you a couple of good Git repos before the end of the talk today, I think that's going to make your life a lot easier. SSL HTTPS. So by default, .NET applications, the microservices get spun up with SSL enabled. So you have a local certificate, you trust your local certificate, everything is HTTPS, which is good. That's positive, good way to do things. But that being said, in the cloud native world, that's not always how things go down. Sometimes you'll terminate that SSL before you get to your application. Again, making the complexity in your infrastructure versus in your apps. And then your apps are just kind of, dumb, quote unquote, HTTP services that don't really care about that. So just as a pitfall, when you run Dapr, especially trying to figure it out locally, the expectation is that your apps don't have SSL enabled. Now, there are options within Dapr to enable SSL and get that set up, but when you're learning Dapr and trying to figure it out and get all these other things up and running, that's just another thing that makes your life more difficult. So just be aware of that pitfall. It's not like it's difficult to get around. It's just another little speed bump of confusion that gets thrown in your path. Docker debugging. Docker debugging is approximately 5,000 times better than it was a couple of years ago. At one point, we had Docker support in Visual Studio, but I just never got it to work correctly. And that is no longer the case. Not only does Visual Studio have really good Docker support, also using just right clicks, you can add Docker support and Docker Compose support to your application, which is kind of cool. And it will build all of your containers and give you an initial Docker Compose file that you can edit. So that experience is a lot better. But even so, it still takes a while when you hit that play button in your application to spin up your containers. It takes longer than would be ideal to get that rolling. So even though the support is there, it's definitely not perfect. It's I would say maybe 7 out of 10, whereas a couple of years ago it was maybe 4 out of 10. So we're almost there. It's just a little pokey. Maybe I just need to get a new computer. I don't know, but I had issues. So with that, I'm willing to take a few more questions or comments before we move on to the demo. So does anybody have anything to say or any questions before we move on? Cue the Jeopardy music. I'll take that as a no. Alrighty, with that, we are going to move on to the next phase. So let's talk about an actual example. If you want to try out different storage containers, you just create a local or a dev or whatever. I think in that case, you just create different components and then you would deploy. Like I would probably create like a dev components, local components folder, and then I would alter my Docker compose to point at those different folders as I go through the environment. So I can show you like what I would do in the example code in a minute. But I would vary my Docker compose as opposed to the, and then have different component folders. So we're going to do a little bit of Jitsi switching. We'll see how this works. So we're going to select another screen. Let's see. I got like a huge list. So there we go. So, and boom. Okay. So let's talk about a little scenario. So let's say that, it's gotten real lonely during the pandemic. All my D&D buddies ditched me because they had kids and stuff, which is inconvenient. So I decided to write, I'm going to write a D&D generator. So it's going to generate encounters for me, and I can play D&D by myself. I don't need no stinking people. So that's what we're building. And, because it's a demo app, it's definitely not anywhere near done. But we do have a couple of services. So the first service we have is an item service. Probably have a good guess of what that item service does. It manages items. We also have a character service, so that manages characters, right? But the thing about characters is that characters have inventories, and inventories contain items. So in our parlance, we need to be able to have a character. So if we come down here, we have Bob McAdventurer, and Mr. Bob McAdventurer has items, one of which is the basic cloak. Now, these are true microservices. Their databases are separate. So we have a character database and an items database. These are independently deployable, independent data, but we need items, right? And so in the microservices world, if we're building a distributed application, we need to be able to create pub sub architecture to share those items back and forth between the services. So like, for example, if I come into my item service and I decide to change the definition of my cloak, we're just going to update that definition. So wait a minute. Okay. Spelling is apparently not my strong suit today. All right, so we have this update. We're going to update. We're going to execute. And so now we have updated our item database, right? So that's cool. But we need to update our character database. Fortunately, we are running Dapr. And so that's all set up. And if we come in here and shablambo, look, it's updated here as well. In a monolithic application, this is like the least impressive demo ever. But in a distributed application, there's definitely a little bit of wiring to get all this to work. So we have a situation where we're using the pub sub architecture to do that. We also have some caching in the item service. So if we come in here to the items, we have our items cached for rapid feedback. Not exactly easy to tell when we're running locally, but just trust me. I'll show you the code in a minute. It's definitely getting cached. So we have some stuff going on here. And so if we want to look at the code, let's shell out to that. So we're going to swap windows awkwardly. Thank you, Jitsi. Just to prove that my databases are, actually, never mind, we're not going to do that. So if we pop over to here, and boom, here we are. Okay, that flickers for me, but not for you, so that's good. At least it doesn't look like it. So if we pop over here to our code, we have a couple of things going on. So we have our character service, which is independent. We have an item service, which is independent, and we're running. I'm actually just going to kill this right now. Okay, so we're just going to kill that to make this a little bit easier. So we come into we'll start with the item service. So if you have anything that you want me to demonstrate or specifically or to call out or anything like that, just go ahead. Right now what we're going to do is we're going to start at the code level, and then we're going to kind of trace through the code, and then we'll look at the Dapr/infrastructure side, if that makes logical sense. But if you have any questions, just go ahead and toss them out. This is the discussion portion of things. So we got our item service. So if we come down here, we have service, data domain, unit test. So if you pop into our domain, we have an item service. That item service has a couple of methods, and what we're doing is we are dependency injecting our Dapr client into our item service. So this is part of the Dapr SDK, and it's a NuGet package that you can install. So we dependency inject that. We come into here. So whenever we add an item, we're going to clear out our cache with just this one command. If we want to, when we update our items, what we're going to do is we check to see, we update our item here using just standard update code, EF framework type of stuff. And then when we're ready, we publish an event. And so what we're doing is we're using our Dapr client to publish an event to our Dapr pub sub component. And then down the road, that'll get read by our, that gets sent over to all the subscribers, one of which is the character service. And then, of course, if we update our item, we need to clear out our cache, which we do using the Dapr SDK. In addition to this client code, we also need to set up a few things in our program CS. So if we come over here, we need to add Dapr to our controllers. So just this add Dapr, and then down here, we need to add use cloud events and use the subscribe handler, which, not all of this, sometimes, each individual component has like a specific integration that it can use, but you can look at that in the Dapr API. That being said, most of these have a pretty minor bit of setup in, you have to usually add some middleware, a bit of configuration, and then you can use, or you can just use the client. So that's our item service. Pretty simple. If we pop over to the character service, we again have some setup in our program CS. So we're using cloud events, subscribe handlers, and also using Dapr. There's a little bit of circular references in that character object, so we had to add a little JSON magic here to prevent us from tearing a hole in the space-time continuum and having an infinity loop of serialization goodness. So good times. So in order to use that, this is pretty nice. So to subscribe to that topic in your code, you got to do a lot of things. By a lot of things, I mean you just have to have this one line of attribute code. Pretty sweet, right? So all this does is just it adds this line, this topic line. We point it at our pub sub component, and every time that subscription comes through, it's going to execute this method right here. So this item change method, so it's basically just going to pop this REST request every time we have an update item. And if we pop into here, if we do a little bit of peek, there's no magic here. It's just code. It's just like standard EF framework, get the thing, change it, and save it code. So to compare to this one line of code and a few lines in the program CS, I have a demo from another talk I did maybe a year or two ago. So I'm going to share that real quick just for fun. So if we stop sharing, if we share again, we're going to find this little guy right here. So this is the service bus handler that I wrote for another application that does the same thing, except it just talks to a service bus. So in order to do that, you come into your program CS, and you have to add a hosted service. Let's see, is the type CS duplicated in both character? Yeah, but it doesn't have to be. The type, it is duplicated, quote unquote. Though theoretically, if you were running this for reals, you could do like a domain project or something and share those across. Like, there's no reason there have to be. A lot of times, if you're doing a distributed application, like in the item service, your item will have let's say 10 different attributes, and then you need 3 of those in your character service. So those objects can be different in different contexts of the application. So if I have an item, maybe I have an inventory ID or something, or I have a bunch of other additional information that goes with the item. Whereas in the character service, you might not care. Or alternatively, you might actually have more information in other services. So like if you have your item service, but then you have like a store service that also uses items, and maybe it has a bunch of extra information. So those items can be different in different contexts. So in this case, they are duplicated though. But in order to do that in this service here, so it's the same kind of thing. We're basically responding to an event. We have to add a hosted service. So this is basically a process that runs with your application that just constantly runs, and we call it Topic Watcher. So you pop into here. The Topic Watcher is a bunch of code that essentially listens to a service bus and then gets this setup order update listener, which is a function that then uses a whole service bus handler that we created, or that I created, to abstract that away. So whereas it's one lousy line of code in plus a few lines in your CS in your program setup, it's like 3 different files in this monstrosity over here in the service bus application. So you're saving a ton of code that you don't have to maintain anymore by using Dapr. And you can multiply that by every single thing you have, because everything you do that talks to the cloud, you're probably going to set up some sort of abstraction in your code, because you don't want to directly talk to any kind of infrastructure in your code. So you're going to set up something like this for everything. You're going to do it for storage. You're going to do it for service bus. You're going to do it for whatever. And so with Dapr, you don't have to do any of that. You just have to have, you just throw in Dapr and you don't have to maintain all this cruft. So it's I don't know. I think it's pretty handy from that perspective. It's pretty good amount of code savings. So with that, let's kick that out of here and let's go and look at some actual Dapr stuff. So if we pop into, let's see. Alrighty, so this is just the Visual Studio Code version of the application. Same thing that I showed you a minute ago, just in a different area, so we can look at the infrastructure code. So if we pop in here, these are our Dapr components. So I put them in a folder in components. If we had different environments, we could do like components dev, components local, et cetera, but this is a demo app, so we just have components. And so in this case, we have 3 components. The first one is going to be our storage. You saw this up at the top, up in the slides. So this is just a Redis backing, just backed by Redis, and we just use a local Redis container. We also have a pub/sub component that also uses Redis as the backing container, just because it's easy to spin up. So we can just run a single Redis container. We can back both of these components with the same Redis instance. When we go to the cloud, we'll do something different. But here we're just doing Redis because it's easy. And then if you have a pub/sub, component, you also need a subscription. So here's our pub/sub component. That's the D&D app pub/sub. And then we also have a subscription that connects to that component. And we have our topic and our route that we set up. So those are our components. We also have a Dapr config. This is mostly, this is pretty much just boilerplate. Zipkin is a monitoring solution. Haven't had to mess with this too much. So with those components, then we need to set them up in our Docker files, or then we need to set them in Docker. So each of the services has its own Docker file that goes with it. Let's see, it's right here. This is pretty much the default like Microsoft right-click add Docker support Docker file. So we're going to come in here from the base. We're just going to get that ready to run our applications from. So we're doing a multi-stage build, which is kind of the default way to do it in Microsoft land. We copy up our services, our CS proj files. We do a .NET restore to get all of our NuGet packages. We copy the rest of the files. We switch to the character service directory, and then we build our projects, spin up a new container that runs our publish code, and then we copy our published artifacts into our final container to run that. So this is items, looks almost exactly the same. So just pop in here real quick. items file. Oh, look, it's exactly the same, except, the services are a little different. We're also making sure the context is set up as the item service. So this basically runs from the root of the project right here. It runs from the context of these Docker files. So if we pop up to the Docker Compose, we have our root Docker Compose, and we are referencing our context. So in Docker world, context is super important because we're copying files from the local machine. So we need to make sure, keep that in keep track of that in our heads. I know this is like a super common mistake for me, is just not remembering where the context is. And I'm like, well, why can't you find the files, Docker? And it turns out the context is wrong. So something to keep aware of. So all the containers are basically running like they ran next to this Docker Compose. So when you set up all of your relative file paths, that's where you need to set them up from. Points to the character Docker file. We expose a couple of ports. This 3001, this is going to be the mapping for port 80. So this is the port you're going to look at. So when we looked at the character service, it was at 3001. And then this is the Dapr port. So we need to expose that port so that the Dapr API can talk to stuff. Then we have our Dapr sidecar, pulling the Dapr image. That Dapr image depends on this one right here. And then in our network mode, we set it up for service, and then we use the name of this, this instance. So basically this allows, this basically creates a network connection between these two things, tightly couples them, and allows them to talk back and forth to each other. We do the same thing over here in our RPG server, or our item service. It gets its own little buddy sidecar. We have our Zipkin and Redis containers, which are just kind of the defaults for backing services in Dapr. And then down here, we kind of have our central Dapr node. We also have an override file. And in that override file, we're going to update some environment variables, and we're going to add this volume. So locally, this volume allows us to mount our user secrets. So those are in our user folder for our project, so we can mount those so that it can use those to configure our local development. And then in the Dapr containers, we run the dapr-d command. And there's a couple of important things in here too. So this app ID, basically this is for security. So when you scope your components, you can scope them to this app ID. So you can say only the character service can look at this component, or, et cetera, et cetera. We set up an app port, which is going to be 80. We have our placement host address, so we set that up with the Dapr placements. And then we set our components path and our config, which correspond to, if you go into the project, that's going to correspond to this folder right here. Oh, lost the screen. Do I need to bounce the screen real quick? Here, we'll just, no. All right, we'll just pop out and we'll throw that back in. Thanks, Jitsi. I was on a roll over here. Here, let's do that again. We back? All right, cool. Thanks for throwing that out there. All right. All right, so in our override, so just kind of rewind a little bit, we have our, our pair of containers. So this one runs the service. This one runs Dapr. We have an override file. So the way these override files work is that when you run Docker Compose, basically you can add additional files to your run. So you say, look at dockercompose.yml, and then also look at, override, and you can override for each one of your environments. So I could do, local dev, QA, prod, magic unicorn environment, really whatever you want to do. In our case, it's just called override. So if we come in here, we have our Dapr command. And so what we're doing is we have our app ID, we set that to character service. So we, when we're scoping components and things, we can scope them to the character service. We have our app ID, our Dapr placements, ports. And this is, the way this is set up is that this Dapr placement port, this corresponds to this service name right here. So instead of having to put in like a network ID, we just say Dapr placement, and then Docker Compose will fill in that for you. We are looking at the components path, and we also have our config. So those things are specified, and those correspond to the items in this Dapr folder. And so the way we're setting that up is we set up a volume where our infra Dapr maps to /Dapr in the container. So this /Dapr comes from here, which we map to this folder path, which is right here. So infra Dapr gets mapped there. That makes sense. Same song and dance for the item service. Pretty much all the things are the same, except we call it an item service instead of character service. For Redis, we're tossing in the image. We're setting up a port mapping. Zipkin's the same deal. And then in the Dapr placement, we set up a placement command. We set up our port and log level, and we just map our 50,000 port to 50,000. And that is how that is done. So that concludes all of the code that I have. And if you want to check this out and run it yourself, that's on GitHub if you want to do that. But I'm also going to point you to some other repos as well. Does anybody have any questions on the code? All right, I'll assume that's good. So we're going to pop back into the slides to close this out. So let's see here. Welcome to Jitsi. We get to go back and forth because I have a widescreen monitor and don't want to share my whole screen. Good times. Let's see. Dapr slides. All right. So now we're back to the slides. Pop down here. So resources and next steps. Dapr is new, so Stack Overflow is not really going to help you a whole lot. But what is going to help you are the Dapr docs. So those are, just on the Dapr website. They're great, especially for high-level information. As a .NET developer, I found the Dapr for .NET Developers book to be absolutely clutch. And the nice thing about both these resources is they are gratis, free. They cost no money. You just search for them, and bam, there you go. I found them both to be rather valuable. Like I said before, repos are really important in Dapr land, just because, at least for me, I have found lately that I would rather just skip the book and look at code, show me the code. And that tends to help me figure things out, especially if it's any kind of like complex infrastructure-y type of stuff, like with Bicep and ARM templates, with setting up things in the application, with Dapr, all of those kind of things. I just, I'll read the high level stuff and that's good. But at the end of the day, just show me the code. Specifically among here, this right here is going to be your boss example, this eShop on Dapr repo. And the reason this is good, and this is actually referenced, so the Dapr for .NET Developers book, that references this eShop on Dapr. So if you've followed the Microsoft Docs people for a while now, they have this application called the eShop. It's basically like their kind of default demo application that they write, and so they will they will run that. They'll run that in a bunch of different formats. So they have like a monolith version, they have a microservices version, they have a Docker's version, and they have they have a Dapr version. And that was the repo that really helped it click for me. Like, I was having a little bit of trouble getting everything set up correctly, just getting random errors until I saw the eShop example, and I was like, oh, okay, well, this is how it's supposed to be set up. And then my life was much easier from that point out. So I recommend, if you want to learn more about this topic, read those books, or read the book, read the docs, and then check out this repo right here. These other two repos, the samples and the quick starts, are also really good. So for each individual component, you have different samples that you can see that component in action. Also, the Dapr docs are really good because each component has different, each component supports different infrastructure components, so you can figure out whether it supports the stuff you like or that you want to use, or you can use that as an influencer for those decisions. So how I would find out more about this topic. So, takeaways. Dapr is dependency injection for infrastructure. So if you like a dependency injection in your applications, you might like it for your infrastructure, and Dapr will give you that ability. Dapr is super good for cloud-native distributed apps, less good for things that are not that, but not necessarily useless. Just that's the type of stuff it's written for. It's written to solve that subset of problems. And ultimately, if you're trying to figure out your way around Dapr, go find the source code. Skip Stack Overflow, skip trying to find all the books and stuff. Just go find some source code, and there's a lot of good examples out there from people who have figured it out for you. So read the source. And with that is all I have for today. So if you have a distributed app, go check out Dapr. It's good stuff. If you want to check out any of the slides, those are available at the GitHub link right there.